Okay, this question was posted well over 2 years ago, but I thought I'd give an answer using Desmos to show how you could do some of the calculations more quickly. So you're given this function 2 over x, which is this red graph. There's actually another branch over here to the left of the y-axis. You're given the point on the curve with an x-coordinate of 0.2 and a y-coordinate of 10, f of 0.2. And that's this point right here. And you're given several points with x-coordinates that are close to 0.2 and asked to estimate the slope of the tangent line. Well, this green dashed line is the tangent line, and it actually does have a slope of -50. This blue line, which joins point P and point Q, is called a secant line because it passes through 2 points on the curve. The tangent line only touches the curve at one point. In this case, point P is the point of tangency. And what this table shows here is that for each of these x sub 1s, this column is the corresponding y coordinate for a point on the graph. You can see that when x is 0.2, y is 10. This column is the change in x, or the change in y, between 2 points, point P and the point that has an x coordinate of x sub 1. This column is the change in x, p dot x minus x sub 1. And if you put the change in y over the change in x, rise over run, that is the slope of the secant line. And so using that, I was able to write the equation of this blue line because I know the point, I know a slope, and I know a point that it passes through. And the idea is as point Q gets closer and closer to point P, this slope will get closer and closer to the slope of the tangent line. And that's what you're supposed to notice here, that here I'm really close to point 2. And here I'm really close to point 2. And those slopes are really close to -50. But if you try to use the slope formula at point 2, you get undefined because the change in x is 0. So you need calculus to find the slope of that green tangent line. So I'm sharing my screen. I'll go to Desmos, and I'm actually going to slide point Q. Well, there we go. Closer and closer to point P, and you'll see that the slope in red is going to get closer and closer to -50. There's -125, -100, -62.5. Here I'm really close, 0.19. Now the slope of the secant line is undefined because I'm at exactly 0.2. The change in x is 0. And now the slope gets farther and farther away from -50. Okay, so that green line again is the secant line. The blue line is the secant line. The green dashed line is the tangent line. And if I click here to the right, this row right here, row 8, is the equation of the secant line because this is this coefficient right here. That's the slope of the secant line. And x sub 2, f of x sub 2 is a point that the curve passes through. There you go. Get back to here. I'll close this and I'll post the URL to that Desmos graph so you can take a look.